Okay, so the classical neurotransmitters that we've been discussing, right? Acetylcholine, dopamine, norepinephrine, serotonin. These are also sort of classed together as what we call modulatory neurotransmitters. And, these are, again, the classical ones that are, modulatory. This means they were discovered or, examined or discussed first. However, there are other neurotransmitters that you release in your brain that are also considered to be modulatory neurotransmitters, and I'll define this term in a moment. But they share certain structural and also functional characteristics. All of these neurotransmitters together. So all of them, okay, have at least one source. One nucleus. Where you find the actual cell bodies for the neurons that will release each of these specific, modulatory neurotransmitters elsewhere in the brain. At least one nucleus in the brainstem. So, for example, dopamine, has two sort of brainstem sources. Remember, there's the substantia nigra, which projects into the basal ganglia, specifically into a subset of basal ganglia nuclei called the striatum. And that nigrostriatal pathway is, of course, associated with movement. And there's also the VTA, right, which is another source of dopamine neurons, and their axons project out, and they form sort of two pathways, right? One goes into limbic structures important for emotional experience and expression, including hypothalamus, nucleus accumbens, right? And then there's another, VTA originating pathway that goes up into the, the prefrontal cortex. And, the first is called the mesolimbic pathway, and the second is called the mesocortical. And, collectively, these are important for motivation, right? And then there is serotonin. I think I neglected to mention there's a specific set of nuclei that are the source of serotonin projections throughout the cerebrum, and they're found in the brainstem. These are called the raphe nuclei, and the raphe nuclei are the source of neurons that are going to release serotonin sort of elsewhere in the brain. Many of them in the frontal lobe, but elsewhere in the brain as well. And then I didn't mention this one either, but acetylcholine is another, modulatory neurotransmitter, which has a brainstem source, right? Interestingly, it has more than just a brainstem source. There's also a forebrain source of acetylcholine that appears to be more critical, for the memory and cognitive effects. But there's this brainstem source that projects up primarily to a structure called the thalamus. And this brainstem nucleus is a very, very long name. So I'm just going to tell you it's called the PPT, is the source of acetylcholine, projecting forward to the thalamus, in the brain. And there are other neurotransmitters, too, that are going to have a similar kind of an organization structurally, like a brainstem nucleus, and then rather widespread projections throughout the cerebrum. Histamine is one, for example. That's another, neurotransmitter that's released in your brain from, a specific source in the brainstem, and there are projections, axons that go and make synaptic connections, widely in other areas of the brain. Okay, so all of these neurons are sharing certain neurotransmitter systems are sharing certain structural features, right? They have brainstem nuclei. They project pretty widely around the brain. Each of them in turn, we've discussed, have some specific sort of functional roles, right? Again, dopamine, movement, motivation, etc., right? Well, at the same time, collectively, they also seem to share a certain functional role. That is, when you are awake and alert and engaged and paying attention and, focused on the task at hand and, things are coming with relative ease, right? Well, there's a relatively high level of activity in all of these brainstem nuclei and relatively high rates of, release of all of these modulatory neurotransmitters. And as you, start to drift off, as you start to pay, less attention and you have a little more troubles focusing, and you feel a little more fuzzy-headed, and you get drowsy and sleepy. Well, the level of activity in these brainstem nuclei, begins to decline, right? The actual firing rate, the number of action potentials per second, right? The frequency of firing, declines, and the amount of these neurotransmitters being released is dropping as well. And if you are completely asleep, in what we call a kind of a slow wave sleep, a really deep sleep, you're not dreaming, but a really deep sleep, well, effectively they are not firing any action potentials at all. They're pretty much silent. And you don't have any dopamine, you don't have any norepinephrine, you don't have any serotonin, you don't have any acetylcholine, you don't have any histamine. None of these modulatory neurotransmitters are being released in your brain. So you should have a relatively good idea of what it is that these modulatory neurotransmitters are actually modulating. They're literally modulating the sort of level of the overall level of alertness. And it turns out that you need a certain level of alertness, right, in order to engage attention, memory, language, decision making. Any of these higher cognitive abilities require a certain level of brain activity and of modulatory neurotransmitter release. Interestingly, I'll leave you with this thought. When you drift into what we call REM sleep, right? Rapid eye movement sleep with your eyes going back and forth, which tends to be associated with dreaming sleep. So if you wake people up during a REM episode, they tend to report, having been in the midst of some dream. The other modulatory neurotransmitters are not firing, right? There's no activity in those nuclei, but one selectively pops back on, and it is acetylcholine. All of a sudden, there is significant acetylcholine release, almost as if you were once again awake. But that's very selective in terms of acetylcholine.